What are the digits given? 1, 2, 3, 4 and 5. From this we are going to form a 3-digit number. If there is a repetition, so you can use all the 6 digits in the 10th place and even all the 6 digits in the 100th place. So therefore, the required number of ways is equal to 6 into 6 into 3, that's equal to 108 ways. Head and tail 2 events, second time 2 events, third. So totally 2 to the 4 to the 8 events we are going to get. Hello dear students, welcome to this session of mathematics class. I am Mr. Niranjan, faculty Department of Mathematics, Vidhyaashram PU College, the Temple of Excellence. Today in this session I am going to discuss regarding very important chapter, that is chapter number 6, permutations and combinations. This is very important chapter, permutation then combination. So 2 parts, first part is the permutation, then the second part is the combination. So permutations and combinations. Now what is the weightage for this chapter? So usually the weightage for this chapter is you will have one 1 mark question and one 3 marks question and one 5 marks question, totally 9 marks from this chapter. So the weightage for this chapter is 1 mark 1 question, 3 marks 1 question and 5 marks 1 question, totally 9 marks from this. 5 plus 3, 8 plus 1 is 9 marks. Now let us know regarding today what I am going to discuss is fundamental principle of counting and the problems based on a fundamental principle of counting. Now let us discuss regarding, before going to exact definition of a permutation and a combination, let us know regarding the fundamental principle of counting and then the factorial notation, how to represent, how to expand a factorial value. So factorial notation of any number. So based on this, let us discuss. First one is the fundamental principle of counting. What is this fundamental principle of counting, or it is also called as a multiplication principle, principle of multiplication, or it is also called as fundamental principle of counting. So the fundamental principle of counting or the principle of multiplication states that for any 2 events or any 3 events, so statement, that is state fundamental principle for counting, that is multiplication principle for any 2 events or any 3 events. So the fundamental principle for 2 events states that an event can occur in m different ways. Suppose if an event can occur in m different ways, following which another event occurs in n different ways. Suppose if an event A occurs in m different way, following which another event B occurs in n different ways, then the total number of occurrence of the events in the given order is m into n. Suppose if an event A occur in m ways, then another event B occur in the number of ways n ways, then the total number of occurrence of an event, the total number of occurrence of an event in the given order is always equal to m into n. So this is called the fundamental principle of counting, or it is also called as multiplicative principle. So that is, if an event A occurs m times, another event B occurs n times, then the total event, the total number of occurrence of the event in the given order is always equal to m into n. Now let us take an example. Second one, before that, let us know another definition. The fundamental principle for 3 events states that if an event can occur in m different ways, following which the second event occurs in n different ways, following which the third event can occur in p different ways, then the total number of occurrence of the event is given by in order m into n into p. Same as that, that is for the fundamental principle for 2 events. This is the fundamental principle of counting for 3 events. Suppose if an event A occurs in m ways, following which another event B occurs in n ways, following which another event C occurs in p ways, then the number of occurrence of the event in the given order is always equal to m into n into p. That is, the occurrence is given by the product of all the events, that is m ways into n ways into p ways will gives the total number of occurrence of the event in the given order. This is called fundamental principle of counting or multiplicative principle for 2 and 3 events. Now based on this, let us take a problem, right? So what is the problem? How many 3-digit number can be formed from the digits 1, 2, 3, 4 and 5, assuming that what are the condition? Repetition of the digit is allowed and repetition of the digit is not allowed. So we have to form how many digit number? 3 digit numbers can be formed from the digits. What are the digits given? 1, 2, 3, 4 and 5. From this we are going to form a 3 digit number. So this is the 3 digit number from this number. First condition, what is the condition? Repetition of the digits is allowed. So you can repeat the digit. Repetition of the digits is allowed. Okay. Now, if the repetition is allowed, so this is an unit place, unit, 10, 100. So we want to form a 3 digit number. So if the repetition is allowed, repetition is allowed. If the repetition is allowed, the unit place can be filled by 5 ways and the remaining 10th place can also be filled by 5 ways and the 100th place can also be filled by 5 ways. So if the repetition is allowed, if the repetition allowed means all these unit place, 10th place and 100th place can be filled by all these numbers 5 times, right? So that means here, since the repetition is allowed, so therefore the number of ways, repetition of the digits are allowed, therefore the number of ways is equal to 5 into 5 into 5, that's equal to 125 ways. That is the first answer. Since the repetition is allowed, therefore the unit place can be filled by 5 times and the 10th place can also be filled by 5 times and the 100th place can also be filled by 5 times. 5 into 5 into 5 is 125 times. We can form a 3 digit number with the numbers 1, 2, 3, 4, 5 provided the repetition is allowed. Now the second case, this is the first case and the second case. So here if the repetition is allowed, we will get 5 into 5 into 5 ways. That is nothing but 125 ways. This is the first answer. On the other hand, second case, repetition of the digits is not allowed. So what are the digits? 1, 2, 3, 4 and 5. So we are going to form a 3 digit number. So this is unit, 10, 100. So you can fill the unit place from any one of these 3 numbers, any 5 numbers. So that can be filled in 5 ways. If the repetition is not allowed, so then remaining 4 can be filled. The remaining 4 numbers can be filled in the 10th place. And then the remaining 3, what are the elements left? If there is no repetition means only 3 numbers are left. These 3 numbers can be filled in 100th place by 3 ways. So unit place can be filled by 5 ways, 10th place can be filled by 4 ways and the 100th place can be filled by 3 ways. The required number of ways is equal to 3 into 4 into 5, that is 3 into 5 4s are 20, 3 2s are 60, that is 60 ways. So this can be done in 60 ways. So that is 3 into 4 into 5, that's equal to 60 ways. That's it. Okay. This is how we are going to solve this problem, very important for 3 marks. So this is based on the fundamental theorem of counting. Now let us move on to the next problem. What is the next problem? How many 3 digit even numbers? 3 digit even number it is. 3 digit even number can be formed from the digits 1, 2, 3, 4, 5, 6. If the digits can be repeated. So if the repetition is allowed, what are the digits given? 1, 2, 3, 4, 5, 6. So we want to form a 3 digit number. So this is unit, 10, 100. A 3 digit even number is to be determined. See here, so even number. So to get 3 digit even number, the 3 digit number should end with the even numbers 2, 4 and 6. So it will it should end with either 2, 4 or 6, right? Now to get an even number, the unit place, this unit place can be filled by any one of these 3 numbers, any one of these 3 even numbers 2, 4 and 6. So the unit place is filled by either 2, 4 or 6. That means the number of ways we are going to fill the unit place is 3 ways. And the remaining here, the digits can be repeated. So that means repetition is allowed. Then how many numbers are left over? All the 6 numbers you can place in 10th place And again remaining 6 numbers, all the 6 numbers can also be placed in the 100th place. So that means the unit place can be filled by 3 ways and the 10th place can be filled by 6 ways, 100th place can also be filled by 6 ways. So therefore the required number is equal to, therefore required number of ways is equal to 6 into 6 into 3. 6 6 are 36, 36 into 3. 6 3s are 18, 1 3 3s are 9 plus 1 is 10, 108 ways. So 108 ways we can fill the 6 numbers 1, 2, 3, 4, 5, 6 to get a 3-digit even number. That's it. Okay, this is how we are going to solve this problem. Right, very simple. Since a 3-digit even number can be formed with the digit 1, 2, 3, 4, 5 and 6. Since this given problem contains 2, 4, 6 as the even number, there are 3 even numbers. So to get a 3-digit even number, it should end with any one of these 3 even numbers, 2, 4 or 6. So how many even numbers are there? So unit place can be filled by 3 ways. If there is a repetition, so you can use all the 6 digits in the 10th place and even all the 6 digits in the 100th place. So therefore the required number of ways is equal to 6 into 6 into 3, that's equal to 108 ways. Now move on to the next problem. Third one, how many 4 letters code can be formed using the first 10 letters of English alphabet if no letter can be repeated? So that means repetition is not allowed in this case. So how many 4 letters code can be formed using the first 10 letters of English alphabet if no letter can be repeated? If there is no repetition, how many 4 letter words can be formed with the 10 letters? So 4 letters words with 10 letters, right? So 10 letters of English alphabet. Say, what are the 10 letters? Call it as A, B, C, D, E, F, G, H, 1, 2, 3, 4, 5, 6, 7, 8, H, I, J. See, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. Using these 10 letters, we have to form a 4 letters word. So 4 letter words. So to get a 4 letter words, from 10 letters. So just write like this, 4 letter words. So this is first place, second place, third place and fourth place. So here what is the condition? If no letter can be repeated, there is no repetition means, so you can place the first place, you can fill the first place with any of these 10 letters. You can take A, B, C, D or any up to 10. So the first place can be filled by 10 ways. So once if A is filled in the first place, then what are the elements remaining? What are the letters remaining? There are 9 letters. So with these 9 letters, you can fill the second place. So the second place can be filled by the 9 ways. So suppose if you consider B in the second place, and what are the alphabets remaining? C, D, E, F up to 8. So that means the third place can be filled by the remaining 8 ways. So this C is gone and the fourth place can be filled by the remaining 7 letters. So that means here the first place can be filled by 10, the second place can be filled by 9 letters and the third place can be filled by 8 letters and the last fourth place can be filled by 7 letters. So therefore the required number of ways is equal to 10 into 9 into 8 into 7 ways. That's all. Therefore the required answer means, that is the required word with 4 letters are 10 into 9 into 8 into 7. That's it. Simplify, you will get the answer. So if you multiply, you will get 50 40 ways. That's it. So therefore, the required 4-letter coded word with these 10 letters is 5040 ways we can write. So provided the repetition is not allowed. Move on to the next problem. Problem 4. A coin, one coin. A coin is tossed how many times? 3 times. So a coin is tossed 3 times and the outcomes are recorded. How many possible outcomes are there? So we have to find just only the outcomes, that is the sample space. Suppose if a coin is tossed 3 times, one coin is tossed 3 times, what are the possible outcomes? Suppose if you toss a coin one time, what is the possible outcomes? Either you may get head or a tail, head or a tail. So if a coin is tossed 3 times, let us record what are the outcomes we are going to get. That's it. Okay. So if a coin is tossed 3 times, one coin is tossed 3 times. So what are the first time? You will get head and tail 2 events, second time 2 events, third. So totally 2 to the 4 to the 8 events we are going to get. So what are the events? That is called as the sample space. Let us write all the 3 head, 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 head. Okay. Then first one is head, 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 head. Third one is head, head, tail, head, tail, head. Okay. Head, tail and head. Now first head, then tail, first tail, then head. H, T, 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 H, H. Right. Then tail, head, tail, T, H, T, 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 head, tail, tail, head, and the last tail, tail, tail. Count how many are there? 1, 2, 3, 4, 5, 6, 7, 8. These are the possible events. That's it. See here. So when a coin is tossed 3 times, so what are the possible outcomes we are going to get is 2 into 2 into 2, 2 to the 4, 4 to the 8 outcomes. So first 3 head, 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 last 3 tail, tail, tail. Then head, head, tail, head, tail, head, then head, tail, 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 head, head, tail, head, tail, 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 head, tail, tail, tail. So therefore these are the outcomes. So you can also write like this. S is equal to the sample space head, 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 tail. I'll write properly. Head, tail, head, head, tail, tail. Then again tail, head, head, then tail, head, tail, then tail, tail, head, and the last T, T, T. So these are the sample space. That's it. So that means if a coin is tossed 3 times, the outcomes recorded are, these are the outcomes recorded. So totally 8 outcomes we are going to record. That's it. Right. Now move on to the next problem. What is the next problem? Given 4 flags of different colors, there are 4 flags of different colors. How many different signals can be generated if a signal requires the use of 2 flags, one below the other? Given 4 flags, how many flags are given? 4 flags of different colors are given. How many different signals can be generated if a signal requires the use of 2 flags? So here 4 flags are given. These, let us assume these are the 4 flags. So this is 4 flags are given. So, and we want to generate a signal with the help of these 2 flags. To generate a signal, minimum 2 flags are required. Right. Now let us assume this, out of 4 we are going to generate a 2 flag signal. So if a signal requires the use of 2 flags. Now let us assume that, so this is the first flag and this is the second flag, this is the upper flag and this is the lower flag. Okay. Now how many flags are given? 4. So first flag, that is upper flag, can be found using 4 ways, and once if one is taken out, then the remaining lower flag can be found with 3 ways. That's it. Okay, one below the other. So therefore the number of different color flags can be found is, so the number of ways is equal to 4 into 3, that's equal to 12 ways. So in 12 ways we can 12 ways we can form a different signals can be generated if a signal requires the use of two flags, one below the other with different colors. That's it. Now, different number of signals we can generate it with 4 flags taking 2 of different colors is 12 ways. That's it. Okay. Now, next problem. How many 2-digit? So, 2-digit even number can be formed from the digits 1, 2, 3, 4, 5. So, digits given are 1, 2, 3, 4, 5. With this 5 digits, we want to form a 2-digit number. This is 2-digit number, provided, what is the condition? It's an even number. So, a 2-digit even number is to be formed. Just check how many even numbers are there in the given numbers 2 and 4. So, there are 2 even numbers. 2 and 4 are 2 even numbers here. So, how many even numbers are there? 2 even numbers. So, if the digits can be repeated, if the repetition is allowed. Okay. So, what is required to find is a 2-digit even number. So, this is unit place and 10 place. Since the given numbers so in the given numbers we have only 2 even numbers. So, there are 2 even numbers. Any one of these 2 even number can be filled in the unit place. That is, that can be filled in 2 ways. You can fill 2 or 4 in the unit place. And the remaining numbers, since the repetition is allowed, you can repeat the digits. So, the remaining 1, 2, 3, 4, 5 can be filled in the 10th place. That means the 5 digits can be filled in 10th place. So, therefore, the required number of ways of getting a 2-digit even number from these 5 digits is 2 into 5. That's equal to 10 ways. That's it. Okay. So, the required 2-digit even number. So, this is 2-digit, what is this? Even number. So, you can get 10 2-digit even numbers with this 1, 2, 3, 4, 5. That's it. Okay, very simple. See, since the given numbers contains 2 even numbers 2 and 4. So, the unit place can be filled by any one of these 2 even number, either 2 or 4. That can be filled in 2 ways. And since the repetition is allowed, we can fill the remaining 5 letters in the 10th place. So, therefore, the required number of ways to get a 2-digit even number is 2 into 5, that's equal to 10. That's it. This is how we are going to solve this problem. Very simple for 2 marks, 1 or 2 marks. That's it. Okay, hope you followed. These are few problems based on a fundamental theorem of counting or fundamental theorem of multiplication. So, that's all regarding this session. Let us meet with a different concept in the next session. Thank you very much.